बिस्मिल्लाहिर्रहमानिर्रहीम। इंडिसेस एक बड़ा इंटरेस्टिंग और इम्पोर्टेंट टॉपिक है जो ओ लेवल में तो हमें इसकी ज़रूरत है सिलेबस के हिसाब से भी, लेकिन अदरवाइज भी इसके जो कॉन्सेप्ट्स हैं उसमें थोड़ा सा प्रॉब्लम कुछ बच्चों को रहता है, तो इसलिए इसको एक सीक्वेंस में, एक ऑर्डर में इसके रूल्स को अगर आप याद कर लें, याद क्या मतलब समझ लें अगर इसको, तो आई होप दैट काफ़ी हद तक आपका जो है ये कन्फ्यूजन्स ख़त्म हो जाएंगी। तो इसको हम बहुत ही बेसिक से इसकी बात शुरू करते हैं। तो वो इस तरह से है कि इंडिसेस, द वर्ड इंडिसेस असल में this is a plural word of another word। तो पहले हम इसको देखते हैं कि ये दरअसल इंडेक्स जो वर्ड है ना, दैट इज इंडेक्स, तो उसका प्लूरल इंडिसेस है। दिस इज सेम लाइक वर्टेक्स is a singular word and its plural is vertices. So it happens sometimes that the spellings are quite different in case of singular and plural। तो वो जो इसमें यहाँ पे जो इंडेक्स वो है उसको प्लूरल के तौर पे इंडिसेस हम यूँ लिखते हैं। तो इसका असल में ऐसा है कि जैसे जाहिर है जो इन द वेरी बिगनिंग व्हेन these rules were made, whenever like 3 was written 4 times, obviously somebody would have suggested that instead of writing 3 added 4 times, it's better to write a 4 here, which indicates that this 3 is added 4 times. Or if it is like a not multiplication now, if a is added, a plus a plus a, if a is added 5 times, then it's easier to write this way with an understanding that a is added 5 times. This number multiplied by a tells that a is added 5 times. So initially probably it was easier to write this way, and this number is named coefficient. This is coefficient of a, coefficient of a, 5. Now later on, probably if we imagine this way, that if later on the numbers were continuously multiplied like this, so if it is added 5 times, we used a symbol here. Now same symbol obviously we cannot use here, that option is already attempted. So now we had to indicate in a way that it seems to be different from this expression. So it was suggested that in this case this 5 should be written on top of a. When it is written on the top of a, then it will indicate that a is multiplied 5 times. So if it is written beside a, that is named as coefficient, and if it is written on top of a, that is named as index of a. This 5 is coefficient of a, this is coefficient of a, and this 5 is index of A. So that is the base of this concept of indices. That power is uh, power or index or exponent. These are different words used for this expression on top of it, which represents multiplication of number that many times. Okay, so these are the words we can use. What index? Its plural is indices or exponent or power. These three words are commonly used, and this is most commonly used while talking about indices, like if it is a power, if it is a with index 4, we say that a raised to the power 4. So there is no difference what word is used. Actually, sometimes they are in different contexts, but we will focus on their properties. Okay, now uh, if it is like a power 3 multiplied by a power 4, in order to devise a rule for this, whatever we have learned already, that a multiplied by 5 times means a raised to the power 5. Conversely, if the same thing, if we consider in reverse order, then a power 5 means a multiplied 5 times. So following the same context, we can apply here that a power 3 means a multiplied thrice. This expression is AQ, and then a power 4 these 4, this is for this a power 4, and these 3 are a power 3. Then following the same rule, that if it is multiplied 5 times, power is 5. So here these a's are multiplied 1, 2, 3, 4, 5, 6, 7, obviously. So we can write it as a power 7. After having written this expression, when we compare this expression with these numbers, so we conclude that instead of going into this detail, all these numbers, actually this number is the sum of 3 and 4. So next time we don't need to go into this detail, but what we can do, a power 3 multiplied by a power 4, that is a power 3 plus 4, which is equal to 7. So from here we conclude that if two numbers in index form, there are two numbers in index form and are multiplied, then we can write it as a single value, and the indices will be added. You can see here that these are two numbers with same base. This number, if the 3 is its index, then a is its base. If same base is there and powers are added, they have different indices, then indices are added. So actually another thing what you need to realize and remember, that indices or properties of indices can be applied only if they have same base. If base is not same, then such rules are not applicable on them. So here we could add their powers because base was same. So a power 3 plus 4 is 7. So as a conclusion, we can say that what is the result of all this discussion. Number one, we write it as a rule that if it is a raised to the power x multiplied by a power y, that will be the result will be equal to a raised to the power x plus y. Okay, now we discuss another thing, that power like 1 upon a. If it is in denominator, we can say that its power is -1. If we shift it from denominator to numerator, sign of its power that will change. So this is another interesting rule, that sign will be changed. So let's look into it in more detail, that 6, or let's take some other number like 9 divided by 3. We know that 9 when divided by 3, 3 threes are 9, so answer is 3. Or like 27 divided by 3, answer is 9. 27 divided by 3, 9 threes are 27. Now let's solve the same thing applying indices. 27 upon 3, that is equal to 27, that is 3 threes are 9, threes are 27. So we can write it as 3 power 3 divided by this 3. We know that finally we have got our answer 9. What is 9? 9 is actually 3 threes are 9. That means 3 square is remained. So from here, when we find that this is 3 power 3, this is 3 power 1, and the answer must be 3 power 2, then we can see that actually what has happened, 3 minus 1, so the answer is 3 power 2. So we come to know that yes, whenever there is a power in denominator, its sign should be changed when it is shifted upwards. We should change its sign. So if it was positive, actually here it was positive, but when we wrote it upwards, its sign is changed to negative. How did we decide that it should be negative? Because from here, when we simplified this expression, we got the answer 3 square. So from here we concluded that if answer is 3 square, here it is 3 power 3 and this is 3 power 1, so the difference is the answer. So difference we can obtain when its sign is changed. So we make a rule that whenever there are two values with different indices with same base, that their indices, their difference of the indices will be taken when it is divided. So now let's make a rule of this discussion. Okay, now it will be here. Next one we can write here number 2. If it is a raised to the power x divided by a raised to the power y, we can write it as a power x minus y. Difference of the indices we will take as we have discussed right now. So this will be x minus y. In case of multiplication, it is x plus y. In case of division, this is x minus y. So division is represented in two different ways. If it is written a power x divided by a power y, so what you can do, you can write it x, this is positive, but due to this sign of division, we change its sign here. Look, try to understand the difference. Just a moment. Now look, here it was multiplication. When there is multiplication and this is positive, it remains positive here. In case of division, if it is positive, that positive sign changes to negative in case of division. In this case, it is x plus y when they are multiplied. If it is divided, then it will be x minus y. So these are two different expressions. If it is a power x over x, a power y, or a power x divided by a power y, both of them have same meaning. So that's the reason that they have same result. So this is another result. Okay. Now as we have concluded that, let's say b power 3 means b, 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 written thrice. If it is p power 4, that means p is multiplied 4 times. If I put a bracket here, this way, if I don't know the value inside the bracket and power is 3, but at least I know that whatever is the value, the same value is repeated 3 times with a sign of multiplication between them. This is multiplied thrice. So considering this concept, if I have an expression like a power 2 raised to the power 3, I mean this blank bracket, let's disclose that the value inside the bracket was a square. So if the bracket is repeated 3 times, that means a square, a square, a square. Because of this 3, a square is multiplied thrice. And in the previous rule, we have already concluded that when same base is multiplied, powers are added. So 2 plus 2, 4 plus 2, 6. Once again, with the same approach, when we compare the answer with the question, we come to know that why should we do this? We can obtain same result if 2 is multiplied by 3. So 2 multiplied by 3, that makes 6. So it's very simple that we can direct multiply them. So next time we should not go for this detail. Okay, so but here there is another thing which we should be well aware about, that those things are not applied here in O levels, but if you come across some such things, then you should be careful. Now look, if I write 2 power 3, what is the difference in this one? Same 2 power 3 I have written here, a square power 3 and a square power 3. What difference do you notice? Yes, there is the difference of this bracket. We have put bracket here, but there is no bracket here. So when there is no bracket, it changes the question completely. In this case, a square is repeated 3 times. This many times. This bracket is repeated. A square is in the bracket, so that bracket is repeated 3 times. If it is 5, it will be repeated 5 times. But in this case, a square will not be repeated, but this is the power of 2. So if I write it like a power 3 power 2. If there is no bracket, then it means a power 2 cube. You have to consider it separately, 2 cube. This value is considered this way, 2 cube. 2 cube is 8. On this side, you can see that this is 3 square. Then it will be 9. Okay. On the other side, if I put the bracket on the value, a square cube and a cube square, this will be a raised to the power 6 and this is again a power 6. So there are two things to be noticed, that if there is a bracket, then bracket is repeated 3 times, or in other words you can say that 2 is multiplied by 3. 2 3s are 6. Here, so it doesn't make a difference whether it is 2 3s are 6 or 3 2s are 6. So these are, both of these have same result. But if there is no bracket, then this will be 2 cube. 2 cube is 8, whereas 3 square is 9. If you swap their places, then you get different answer. So this is very important to understand, that this result, multiplying power of a power, multiplying these two powers is only possible if there is a bracket on this value. If there is no bracket, then the result is different. So now we can conclude that if there is a power x raised to the power y is equal to a raised to the power xy, and it does not make a difference if it is a power y raised to the power x, again it is a power xy. So from the result, these two results, we can conclude that a raised to the power x power y is equal to a raised to the power y power x. They are same. They have same result. Okay, this is another rule. Now continuing it, if we have two different values in base, a multiplied by b, and power is, let's say, 4, then it will be a raised to the power 4 multiplied by b power 4. This power is shared by both the number inside the bracket. This is for a as well as b. Okay. If these are two different values, A and B values are different, but if they are multiplied, they are supposed to be a single term. This is a single term if they are multiplied. I mean, if it is this is a common mistake, a plus b power 4, sometimes it is observed that some students write it this way. So this is totally wrong. What's wrong with it? Why is it wrong? Because inside the bracket, it is not a single term. These are two different terms. A and B are different because there is sign of addition between them. So, an important reason of making such mistakes is that students mix up the properties of indices which are applicable on in case of multiplication or division. They apply the same properties on addition or subtraction. Actually, the students who make such mistakes, and their mistake is that they remember half of the total conclusion, whatever is the property. They just remember that this power 4 is shifted to its values inside the bracket, but they forget the remaining part of the property, or you can say that the condition of the property, that when the bases are multiplied, if these two numbers are multiplied, then you can shift it here. If they are added, you cannot shift. So this is the mistake, that they shift here with in this context, but they forget that there is sign of addition or subtraction between them. And this property is not for addition or subtraction. This property is for multiplication or division. How is it for division? Like if it is A over B, then again power is x, let's say, or 2 or 4, whatever, then it will be A power x over B power x. In case of division, again you can this power will be shared by A as well as B, but not in case of addition or subtraction. So this is the rule, that A power x, complete power, A multiplied by B raised to the power x is equal to A raised to the power x, B raised to the power x when they are multiplied. Or this one, as we have discussed, that in case of fraction. Okay. Now, another very common property, that A raised to the power 0 is 1. Now, if you remember this property without understanding, once again you should understand it, that like 5 divided by 5, we know that when in case of division they are cancelled, answer is 1. If it is cancelled in case of addition and subtraction with opposite sign, answer is 0. And in case of division, answer is 1. Okay. Now, if it is x cube divided by x cube, there are same values. After dividing, answer will be 1. So, before considering something else, this is confirmed that answer will be 1. Okay, now on left hand side, if we solve their indices, if we solve them, even then answer won't change. That will remain 1. So x power 3 minus 3 this will be x raised to the power 0, that is 1. So now a raised to the power 0 is 1. It tells us that whatever its expression was before becoming 0, like this x, they had same powers in numerator and denominator with same base. Now, or in other words, there are exactly same values in numerator and denominator. Then whenever they are exactly same, the power will become 0. Like in case of 5 over 5 is 1, but if you solve it in the similar way, that 5 over 5 after simplifying it is 1. So solving their powers 1 minus 1. So this is 5 power 0 is 1. Now once we have concluded that power 0 means they are same values, power 0 means they are same values. So we can conclude that whenever there is a power 0, like whatever is the value, like 1000 power 0 is 1. If it is 100,000 and power is 0, then it will be 1. If it is 3 over 8 and power is 0, it will be 1. So wherever you find that power is 0, you can replace it by 1. So that's what you have to remember. Okay, now we will talk about fractional indices. Fractional indices. If it is like a power 1 upon 2, you know that this is written a. But if it is a raised to the power 1 upon 3, once again it will be a will be here and 3 will be here. I write 1 or 2 more, then you will understand this way of writing. If it is 2 over 3, 2 and 3. What does it mean? That whenever there is a fractional power, numerator always remains with the base and denominator is written here, and we can read it in a way that cube root of a square. A power 2 upon 3 means cube root of a square. Now it is not necessary that the denominator is always larger, but if it is a power 2 over 5, this is fifth root of a square. But if it is a power 5 upon 2, then numerator will remain with base and denominator is to be written here, but we write every denominator here 3 or 5 or any other denominator, but not 2. If there is nothing written over here, it is understood that this is square root, that power is 1 upon 2, as we have written in the beginning, that a power 1 upon 2 is this. We did not write 2 here because it is understood that it will be 1 upon 2. So this is fractional index. Now solving fractional indices, like if it is 2 upon 3 plus and the other value is, let's say, a power 2 upon 3 multiplied by a power 1 upon 3, then it will be a power, we have already discussed, no matter the indices are integers or fractional powers, but in any case, if the base is same, the powers are added. So these indices 2 upon 3 plus 1 upon 3, that will be 3 upon 3, that is 1. Or some other indices like a power 3 upon 4 plus multiplied by another a with power like let's say it is 5 over 6. So in this case, what we can do, a raised to the power 3 upon 4 plus 5 upon 6. We'll take their LCM, and LCM I had suggested that whenever you have to take LCM of such smaller numbers, just read out the table of one of the larger number, 6. 6 ones are 6 is not multiple of 4. 6 twos are 12. 12 is also multiple of 4, so 12 is their LCM. Now 12 divided by 4 is 3. 3 multiplied by numerator 3, 9. Divided by 6, 2, and 2 fives are 10. So this will be 10. And we get the value a raised to the power 19 over 12. Now this is an improper fraction. First of all, we change it to a proper fraction. 1 whole 7 upon 12. 12 plus 7 is 19 actually. Now further what we can do, a raised to the power 1 plus 7 upon 12. So you can write it as a power 1, reverse application of that property that when bases are same, powers are added. So this time we have separated them because powers are added. So it will be a will remain here multiplied by under the root, and numerator will remain with the base and denominator can be written here. So it can be written in this form as well. So that is the result. So as a conclusion, you can say that a power m over n is equal to a power m, and this is nth root of it. We can write this way. And addition, you have seen that how we can add fractional powers. So now if we conclude all the results, like first it was a power x and a power y, this is a power x plus 1. Second, we did that a raised to the power x divided by a power y, that is equal to a power x minus y, or similar expression can be written this way, a power y is equal to a power x minus y. These both are same. Third, a raised to the power x power y is equal to a power y x and In both of the cases, it is equal to a power xy. Then next, I write here so that all the properties remain on the screen. I can write one more here. So number 4, a multiplied by b raised to the power x is equal to a power x and b power x. That power is shared by both of them. Once again, I repeat that if there is sign of addition between them, then this property cannot be applied. Now, number 5, a over b power x, that is a power x over b power x. In case of addition or subtraction, multiplication and division, power is shared by its bases. Okay, number 6, we concluded that a power 0 is 1, and number 7, a power m over n is equal to a power m nth root. These are all the properties which you can see here that can be used in different questions. I think if you have watched all the properties I have explained carefully, then I hope that you won't have any problem in future about indices. So still we will do some practice questions because I have only explained the rules. We have not practiced the questions. So I will make another video about practice questions, and then another one about questions from past papers. Both of the things. If you follow the same things regularly, then I'm sure that you won't have any problem in indices at least. So that's it. Allah Hafiz.